Dear gate aspirants, network subject easy or difficult? Network subject easy or difficult? Many will feel network subject as a bit confusing and difficult. Reason, they are not perfect with series spell reduction techniques. If you are perfect with series spell reduction techniques, all the single source problems you can play like anything, DS. It's very easy to solve all the single source problems. Let us analyze with series spell reduction techniques. I will give beautiful conclusions, beautiful techniques in understanding the series spell reduction techniques. Shall we start, DS? Yes. How these two elements connected, DS? Let us take some values. Let me take some value here, 10 volts and 1 ohm. Come on, engineers. How these two elements connected? In series or in parallel? Many will say, sir, current here is 10 amperes and voltage here is 10 volts, and students want to say they are connected in series. So current here same, they want to say these two elements are connected in series. Many will say, sir, here the voltage is 10 volts, here the voltage is 10 volts, they are connected in parallel, which is wrong, dears. Reason, two resistors connected in series, what is the equivalent we write? R1 plus R2. Two resistors connected in parallel, what is the equivalent we write? R1 R2 by R1 plus R2. Here you said, or you are thinking that these two elements are connected in series. Will you write, if I ask the equivalent, will you write the equivalent as 10 plus 1? No, na. So you said, some people said these two are connected in parallel, will you write the equivalent as 10 into 1 by 10 plus 1 ds? Obviously no. Hope you got the point. To speak about series or parallel, at least two elements should be there. To speak about series or parallel, at least two elements should be there, ds. Fine. Let us go with one more analysis or one more circuit. Two resistors I am taking and I am giving two sources like this, R1, R2, some V1, V2. Come on, sir, you tell me how these two elements connected. How these two elements connected, sir? Series or parallel? Some answers, some are saying series, some are saying parallel. Huh? I am listening to your answers, yes. Series or parallel? Some say, sir, both series and parallel. Some say neither series nor parallel. Which option is correct? For both the circuits, the answer is neither series nor parallel. Neither series nor parallel, dears. Fine? Why, sir? Why neither series nor parallel? Yes. What are the necessary sufficient conditions to speak or to discuss about series parallel? To speak about series parallel, at least we should have two elements and only one source, should be there. Only one viewing terminal should be there. One source, sir, one viewing terminal should be there. Fine, sir. Finally, we define the series parallel reduction techniques like this. Series parallel is based on physical connection among the elements as viewed from the source. Physical connection among elements as viewed from the source, but not by physical appearance. Okay. What are the necessary sufficient conditions to speak about series parallel, sir? To speak about series or parallel, at least two elements should be there and only one source should be there. Fine, dears. Let us do with some problems and get perfect with series parallel reduction techniques. Come on, sir. Examiner's interest is to ask here, what is ZAB? Exam is asking what is ZCD and what is ZAC and what is ZAD, what is ZBC, lastly what is ZBD. Yes, sir. ZAB. Fine, sir. Hope it's clear to you. Let me compress this. Yes. Fine. Okay. Many want to convert. It appears like a star or a T network for you. Many want to convert this T network into delta. They want to do different combinations. Some will say ZAB as Z1 plus Z2 parallel Z3. Different answers here. Okay. Let me give the technique and the shortcut. Best way of analyzing series parallel reduction techniques. ZAB. Exam is asking ZAB. Please connect a test source between A and B terminals. A test source between A and B terminals with the polarities plus and minus. Fine, sir. Right. We always discuss about conventional current. Current comes like this, and no current flows in this wire. Why? What is law of conservation of charge? Whatever the current that comes out from positive terminal of the supply, same current should enter negative terminal of the supply. I repeat my statement. Law of conservation of charge mean whatever the current that comes out from positive terminal, same current should enter negative terminal of the supply. Is it fine, sir? If current enters like this, is there any path for that current to enter negative terminal of the supply? No path, therefore no current enters. Fine, sir. Therefore, current in this wire is 0 amperes. Finally, to follow law of conservation of charge, fine, sir, yes. To follow law of conservation of charge, whatever the current that comes in Z1, same current flows in Z3, and no current flows in this wire. Current comes like this and enters negative terminal of the supply. Now you tell me, sir, source point of view, current in Z1, current in Z3, same or different? Come on, engineers, same or different? Yes, current is same. Current is same is how they are connected, sir? In series or in parallel? In series. Finally, the answer is Z1 plus Z3. Any doubts? Z1 plus Z3. Any doubt, dears? Hope it's clear for you, dears. Next, let us go with the calculation of ZCD. ZCD means a test source is connected between C and D terminals. A test source is connected between C and D terminals. Again, don't get doubt here, sir. You have connected some DC supply, whereas you have given some impedance here. Okay, it is just a test source, sir. Test source. Fine, right. Again, tell me, sir. Current comes like this. Current comes like this. Current comes like this. Now doubt comes for the student. When you are discussing about ZCD, we don't have this source. We don't have any source here, or we don't have any source here. This current is not there now. When that source is not there, how we get the current from that source? Clear, sir? Fine. This current comes like this. Now this is perfectly open circuit. No current flows like this. Why, sir? What is the reason? No path for that current to enter negative terminal of the black test source. Hope it's clear to you. Next, current comes like this, current comes like this, current comes like this, and enters negative terminal of the supply. Now the source point of view, you please tell me how this Z2 and Z3 connected. How Z2, Z3 connected, sir? In series. Why in series? Current is same. Therefore, here what we write? Z2 plus Z3. Z2 plus Z3. Now, examiner's interest is to calculate ZAC. ZAC, sir. Let me use pink pen. ZAC. ZAC means what? Please connect a test source between what terminals, sir? A and C terminals. Let us connect test source, yes. Connecting test source between A and C terminals. Now please tell me, when test source is connected between A and C terminals, this test source is not there. Only one test source is there. What is that test source, sir? A test source which is connected between A and C terminals. Always current comes out from positive terminal. Why? Because we follow Indian tradition, we follow with conventional current. Current comes like this. Will current comes like this? Come on, tell me, sir. If any current comes in this wire, is there any path for that current to enter C terminal? If current comes like this, can current go like this? No, there is no path to enter C terminal. Can current go like this? We don't have the test source here. This is completely open circuit. Can current jump into C terminal like this? No, sir, not possible. Therefore, current comes. Current in this wire I can write as 0 amperes. In what case? When source is connected between A and C terminals. Fine, sir. Right. Current comes like this and enters negative terminal of the supply. Now, AC terminals point of view or this source point of view, current here is same. Therefore, I can write, what is the answer, sir? Z1 plus Z2. Z1 plus Z2. Is it clear? Yes, please have a look. No hurry, sir. No hurry. Just please have a look. If you are perfect with calculating ZAB, ZCD, ZAC, then we go with further calculations. Please have a look. Clear? Done, sir? Right. Now let us go with the calculations of ZAD. Come on, engineers, you tell me. D terminal, B terminal, both same or different? Do we have any impedance between these two terminals? We don't have any impedance between these two terminals. See, if here the point is D, here what is the point? D only, na? Here what is the point? B only, na? Here what is the point? B only, na? Here what is the point? D only, na? Please tell me, sir, here what is the point? It is B and this is D. B, D terminals are same. When B, D terminals are same, ZAB is nothing but ZAD. Finally, what is the answer? Z1 plus Z3 is the answer. B terminal, D terminal both are same, yes. Clear? Next, what is ZBC, sir? ZBC, yes, no please, no please. What is ZCD? ZCD. ZCD is nothing but ZCB. Why? Because D terminal, B terminal same, na? ZBC is nothing but I can write ZCB, which is also equal to ZCD. Come on. ZBC, ZCB, both same or different first? Both are same, sir. Having any doubt? Okay, understand. First, let me explain ZBA first. ZAB already we have written. What is that, sir? Z1 plus Z3. Let me explain what is ZBA. ZBA. You tell me, sir. ZBA is nothing but positive polarity at B side, negative polarity at the A side. Current comes like this, current flows like this, current comes like this. Means Z3 plus Z1 is your answer. Z3 plus Z1 is your answer. Okay. Z1 plus Z3 or Z3 plus Z1 both are same, na? Means ZAB is nothing but what? ZBA. Similarly, ZBC is nothing but what? ZCB. B and D terminals both are same. So ZCB is nothing but ZCD. So ZBC, ZCD both are same. Lastly, what is ZBD? Lastly, what is ZBD? Source connecting between B and D terminals. Let me compress this. Source connecting between B and D terminals. If you connect source between B and D terminals, current comes like this. B and T terminals, I am connecting the source DS. Yes. When source is there between B and D terminals, we don't have any source other than with in between other two terminals. Okay. Yes. Current comes like this. Current flows in this wire. No current flows, sir. Current always prefers low resistive path. Current comes like this. ZBD I can write as 0 ohms. This is what perfect learning of series parallel reduction techniques here. This is what perfect learning of series parallel. This is how you have to learn, please. Fine. See, in how many views we have gone, we have calculated the impedance, sir. Right view calculated, left view calculated, top view calculated, bottom view calculated, this diagonal view calculated, and this diagonal view calculated. In all the views we have calculated the equivalent impedance, sir. Do you have any view other than this to calculate the equivalent impedance? So why you are taking this much time why you are taking this much time in explaining the series parallel reduction techniques? Brother, if you are perfect with series parallel reduction techniques, calculating Thevenin's resistance will be easy for you. Calculating maximum power transfer and variable load resistance will be easy for you. Calculating time constant and transients will be easy for you. Fine, sir. Right. Please learn series parallel reduction techniques like this. Shall we go with next problem? Yes. Next problem, sir. What is the difference between earlier problem and this problem? In earlier problem, CD terminals are open, whereas now here CD terminals are completely shorted. So let us analyze this. Examiner's interest is to calculate ZAB even for this question. Right. If I ask ZAB, what is the first step, sir? Connect test source between A and B terminals. Test source, sir, dotted lines between A and B terminals. What current we discuss? Conventional current means current comes out from positive terminal. Current comes like this. Current comes like this. Let us call this current as some I. Fine, sir. Right. At this point, whereas at this node, current divides. Let us call this current as I2. Let us call this current as I3. Sir, why you have taken I2, I3 here? Can you take here I3? You can take here I2 now, sir. Brother, simple. Since I have Z2 here, I have taken I2. Since I have Z3, I have taken I3. All these doubt comes for you, dears. Since it's an online class, we are expecting every point in clear. Fine, sir. Right. So, yes, what will be current here, sir? I2. Finally, what will be current here? I2. What is this current, sir? I3. Both currents acts like what? I. Current enters negative terminal of the supply. First, law of conservation of charge is perfectly satisfied. Come on, sir. Current entering means what? Here plus. Current leaving means what? Here minus. Current entering means what? Plus. Current leaving means what? Minus. Now tell me, please. Please tell me, sir. Positive connected to this point. This negative connected here. This negative connected here. Yes, observe please. This point, both the points are same. Why? Because we don't have any element between these 2 points. You tell me, do we have any element between these 2 points? We don't have any element, means both the points are same. I am telling you, sir, please accept. This point, both the points are same. Why? Reason, we don't have any element between these 2 points. Clear, sir? Fine. So, positive connected to one point, negative connected to one point. We can say these 2 elements are connected in parallel. These 2 elements are connected in parallel. Positive connected to one point, negative connected to one point. Both the elements are connected in parallel. Head connected, tail connected. Both the elements are connected in parallel. Fine, sir? Right. Even one more way we can analyze those who are perfect with the KVL sign convention. Let us assume voltage across this as 5 volts. Say means I am assuming this voltage as some 5 volts. Now what is voltage here? Started positive. Come on. Go to negative following KVL sign condition. Started positive. Go to negative following KVL sign condition. Even what is voltage here, sir? 5 volts. Between 2 points, voltage is same. These 2 elements are connected in parallel. 2 elements are connected in parallel. What is the equivalent we write for parallel combination, sir? Yes, please. How this Z2, Z3 connected? In parallel. Finally, source point of view, Z1 plus these 2 connected in parallel. Many will be having doubt even how to draw that parallel combination. Let me explain this. Let me compress this first. Yes. How to draw the parallel combination? One thing, dear, see, simple. Z1 I am writing like this. Z1. Yes. Take either these 2 points or these 2 points. Your wish. I am taking these 2 points. Okay. Between these 2 points, this phrase is very, very important. Between these 2 points, these 2 are connected in parallel. So, what is the parallel combination of that Z2 and Z3, sir? Z2 and Z3, Z2 parallel Z3. Finally, what is the answer? ZAB. ZAB we can write as, hope it's visible to you, sir. Let me slide this. ZAB we can write as, come on engineer, Z1 plus Z2 parallel Z3. Z1 plus Z2 parallel Z3. Now, what is ZAD? What is ZAD? Same answer. Reason, B point, D point, both the points same or different? Come on, sir. Both the points are same. When both the points are same, ZAB is nothing but ZAD. Next, ZAD. Yes. Lastly, what is ZAC? Still same answer. Why? D point, C point same, na? So, for this circuit, ZAB, ZAD, ZAC, all the 3 answers are same. One homework I wish to give here, dears. Open CD terminals. Open CD terminals. Short AB terminals. Now tell me, looking from CD terminals, what is your answer? Looking from CD terminals, what is your answer? Looking from CD terminals, I am giving the answer, sir. Please cross check on your own. Looking from CD terminals, when you close this A and B terminals, yes, current comes like this, current divides like this and like this. Z1, Z3 are connected in parallel and the combination in series with Z2. Finally, the answer Z2 plus Z1 parallel Z3. Fine. Hope you do this. Next, let's go with next question, dears. Next cube. T network is over. Exam has given pi network and is asking for same ZAB. Whatever combinations that are possible, sir. ZAB he will ask. ZCD he may ask. ZAC he may ask. ZAD he may ask. All the possible combinations, sir. So if you solve these three, that is sufficient. Remaining all, you will get the same answers. Fine? Right. Why? Because B and D terminals are same. Fine? Right. Let us go with ZAB calculation. Sir, I will explain with lot of patience. Please, learning stage, we can take infinite amount of time. We can take plenty of time in understanding the subject. Once we understand subject, once we get into problems, we should solve in zero time. At the earliest, with much faster you have to answer DS. Fine? Right. Let us go with ZAB. Test source, sir. Test source I represent with dotted lines. Test source. Current comes out from positive terminal, sir. Let us call this current as some I. At this point, current divides. You come on, you tell me how current divides. Since Z1 is there, what current right here? I1. Since Z2 is there, what current right here? I2. Come on, you tell me, will any current flows here? No. A bit faster, yes. What is current here, sir? I2. I2 current comes like, will any current flows here? No. What is current here, sir? I2. Both currents acts like what? I. Both currents acts like I. Many will be having a doubt, sir. This impedance will eat some current now, sir. So how here current can be I1? Please don't have such doubt, dears. Please feel it's like a pipe and water flowing in a pipe. Whatever the amount of water that enters, same amount of water comes out or not? Same amount of water comes out, yes? Yes or no? Right. So here both currents acts like what? High. You tell me please. Current here, same or different? Same. Means how these two connected? In series. Series combination is connected in parallel with what? In parallel with Z1. Finally, what is the answer? I am writing here, sir. Finally, what is the answer? Z1 parallel with what? Z2 plus Z3. Z1 parallel with Z2 plus Z3. Similarly, sir, a bit faster. Can you answer what is ZCD? Can you answer what is ZCD? Can you analyze on your own? Please put pen on your paper, sir. Please analyze ZCD. What is the answer? ZCD. Pause the video. Please calculate ZCD and check your answer with my answer. Done, yes? Right. Then let me write what is ZCD, sir. Similarly, if you connect a source between C and D terminals, current comes like this, divides between this and this. Whatever current comes in this wire, same current flows in Z1. Finally, Z2, Z1 are connected in series. The combination is connected in parallel with what? Z3. So we write here Z3 plus Z3 parallel with series combination of Z2 and Z1. Z2 and Z1. Some students are asking, sir, please give some homework. You want to do ZAC on our own. I am hearing this DS from you. Thank you. You are interested in calculating series parallel, huh? Right. ZAC, sir. What is ZAC, please? ZAC, Z2 parallel with series combination of Z1 and Z3. Please verify your answers with these answers. Hope you got correct answers, DS. Hope you got correct answers. Fine? Right. What came the next question? First we have taken T network and next question CD terminal shorted. Here pi network. What came the next question? Pi network with CD terminals shorted. Let's go with that question. Hope it's clear. CD terminals are shorted. Even examiner's interest is here to calculate ZAB first. To calculate ZAB, what is the procedure? Follow procedure. Connect test source between A and B terminals. Current I comes like this. At this point, current divides like what? I2 and I1. Come on, engineers. I2 current comes like this. Will any current flows in Z3 and enters this point, or current directly flows through CD wire and enters this point? You tell me. Current prefers which path? Low resistive path or high resistive path? Current always prefers low resistive path. I2 current comes like this. What is the current here, sir? I2. Current in this wire is 0 amperes. Current in this wire is I2. Both currents adds like what here? I. Hope you got the point. See here 0 resistive path. Here Z3 ohms. Always current prefers low resistive path. So I2 current comes like this. Come on, engineers. Now you tell me. Current entering means plus, leaving means minus, entering means plus, leaving means minus. This positive connected to this point. This negative connected here. This negative connected here. Now we have to check whether this point and this point, both the points same or different. Come on, sir. This point, same or different? Same. This point, D point, same. This point, C point, same. Obviously, this point, same. Means between these 2 points, Z1, Z2 are connected in parallel. Finally, what is the answer, sir? Z1 parallel with Z2. What is ZAD, sir? If I ask ZAD, what is the answer? Same answer. If I ask ZAC, what is the answer? Same answer. Yes. Please do one homework, sir. What you do? Open CD terminals, short AB terminals. Please connect test source between CD terminals and give you answer. What can be the answer? ZCD. If I ask, what can be the answer, sir? Z3 parallel Z2. Fine. Is it clear? Got some confidence on series parallel reduction techniques? Got some confidence? Yes? Right. This is how you have to do. Let's go with one more problem. Done? Right. Sir, what is the name of the circuit? T network over, pi network over. This is bridge T network. T and one more bridge is there, na? This we call as bridge T network. Even for this question, exam interest is to go with ZAB calculation. Questions are same, sir. See, any circuit you see, in all the possible directions, you calculate the equivalent resistance. Fine? Why? Because we don't know at what point the load is given in maximum power transfer theorem. I mean, you don't know in transients where the inductor is connected. Why? What is inductor? What is time constant in case of RL circuit? L equivalent by R equivalent. How you calculate R equivalent? Looking from L, you have to calculate R equivalent. How to calculate L equivalent? Looking from R, you have to calculate L equivalent. Okay? We don't know what the positions of R and LD is. Fine? Right. So, ZAB, sir. Let us calculate ZAB for this circuit. What is the procedure, sir? Follow standard procedure. Please connect test source between A and C terminals. Current I comes like this. Fine. At this point, current divides like what? I1. Here current goes like what? I4. Why I4, sir? Since I have Z4, I am taking I4. Come on, tell me. What is current here? I4. What is current here, sir? I4. Yes. I4 current, no current flows like this. I4 current enters like this. Now tell me, I1 current coming like this, I4 current coming like this, both the currents adds like I. Will any current flows in this wire? No, no current flows in this wire. I current comes and enters negative terminal of the supply. You tell me, sir, law of conservation of charge is perfectly satisfied. Whatever the current that has come out from the source, same current has entered negative terminal of the supply. So you tell me, sir, current in Z4, current in Z2, same or different? They are same. Means between these 2 points, no, between this point and this point, this impedance and this impedance are connected in series. Whose point of view? This source point of view. This source point of view, current in Z4, current in Z2 is same, they are connected in series. Now can I compress this? Yes. And how we can draw the circuit further? CDS, I am taking these 2 points. Let me draw here. Taking these 2 points. Between these 2 points, what we have? Between these 2 points, what we have? Yes, Z1. Between the same 2 points, we have Yes, please. We have Z4, Z2 series combination. I can write here Z4, Z2, Z4 plus Z2 series combination. Fine, sir. Right. Here what is connected? For this point, what is connected? Z3 is connected. Here what is connected, sir? Z3 is connected. Here we are having A. Here we are having B. Now tell me, sir, how these two connected? In series or in parallel? In series or in parallel? In parallel. The parallel combination is connected in series with Z3. Finally, the answer here we write as ZAB, we write as Z4 plus Z2 parallel with Z1. The whole combination is in series with Z3. The whole combination is in series with Z3. I repeat my statement. These two in parallel, Z4 plus Z2 parallel with Z1. The whole combination is connected in series with Z3. Clear, sir? Right? Next, let me answer ZCD. For the same question, if ZCD is asked, what is your answer? Come on, sir. If test source is connected here, if test source is connected, fine, right, please observe only with black pen. Current comes like this, or let me erase this first. Let me erase earlier question. Yes, this is what some advantages when we have with online classes, whereas with the offline classes, okay, right, if you ask me to draw circuit for one more time, we'll be not having that much time, dears. We can't draw circuit, just we give circuit as a homework for you. The other analysis we give as a homework for you. Yes or no? Huh? Right, we used to give this as a homework. Done, sir. Right. Whereas in online class we have infinite time, so that we can explain with all the cases. Done, dears? Fine. Current comes like this, so no clumsiness here. Okay, right. ZD, perfect analysis we can do now. Current comes like this. At this point, current divides like what? I2 and I4. Yes, right. I4 current comes like this. I4 current comes like this. Now both the currents, okay, adds like what? I only divide like I2 and I4. Again I2 I4 adds like I. Current comes like this. Clear, dears? Right. You tell me please. What is current in Z4 and Z1? Same or different? Current is same. So here we can write Z4 plus Z1. Z4 plus Z1. The combination is connected in parallel with Z2. Parallel with Z2. The total combination is connected in series with what? Z3. This is what the answer of ZCD, dears. ZCD. Hope it's clear to you. And one interesting question. ZCD, not ZCD, ZAC is one interesting. Let me use a pink pen. Yes, ZAC is one interesting question. ZAC, what do you do? What is the standard procedure? Connect source between A and C terminals. A and C terminals. Fine? Yes. Current comes like this. Current comes like this. Current divides between this and this. How current divides, sir? Here current we call as I1. Here current we call as I4. Next, I1 current comes like this. Will any current comes in this wire, sir? If any current comes in this wire, is there any path for that current to enter this C terminal? No path. No path, sir. Current goes like this, no path. If current comes like this, no path to enter C terminal. Therefore, current in this wire is 0 amperes. When 0 amperes, when source is connected between A and C terminals, current in this wire is 0 amperes. When source is there at A and B terminals, current in this wire we have written. When source is connected between C and D terminals, yes, some current flows in this wire. Hope you got the point, sir. Fine? Right. So current in this wire is 0 amperes. I1 current comes like this. Here the current is I1. Current enters here like some I1. Now tell me, dears, source point of view, current in these two wires is same. These two are current in series parallel with Z4. I can write like, let me slide this. I can write this as Z1 plus Z2. Z1 plus Z2 parallel with what? Z4. Clear? Easy or difficult? Series parallel addition techniques. Series, slowly I am extending the range. I started with a small circuit. My interest is to teach like this, DS. If it is offline coaching, yes, we are limited with number of hours. We have to close the subject in 50 hours. In 50 hours to close subject in 50 hours, yes, DC analysis to explain all these basics will take some 25 hours plus. Coming to transient spot and all, we used to run like anything. Whereas now we are happy to teach in online. Reason, yes, we can go with infinite service for the student community. We can give infinite analysis or infinite concept for the student community, DS. This is what advantage we have with the online classes. Fine. Shall I go with next question? Done. What can the next question? You can guess. Bridge T network with CD terminal started. Okay. Average students, below average students. Yes, my concern is UDS. If you are perfect with series parallel addition techniques, easily you can solve all the single source problems. Stop us. I will satisfy you in short. Slowly I will extend the range, DS. Done. Let's go with next question. CD terminals shorted. As said, CD terminals are shorted. Examiner's interest is to calculate ZAB and all the possible combinations, DS. Let us write, let us connect a test source. Test source, right. Let us call this current as some I. At this point, current divides like what? I1 and come on, sir, listen to your voice. I4. So, what is the current here, sir? What is the current here? I4. Right? Yes. At this point, current divides like what? I2 and I3. This is what we have discussed, right? Yes. Since we have Z2 here, I2, since Z3 here, I3. Currents adds like what? I2 plus I4. Here, what is the current here? I2 plus I4. I2 plus I4, all the three currents adds here like what? I2 plus I4 plus I3. Come on, engineers, you please tell me. I2, I3 is a combination of what? I1. I2 plus I3, I can write like I1. I1 plus I4, I can write like what? I1 plus I4, I can write like what? I can write like I. Come on, sir. Yes. Now you tell me. You tell me, sir, current entering me is plus, current leaving me is minus, current entering me is plus, current leaving me is minus. Positive, positive connected to this point, this negative connected here, this negative connected here. Between these 2 points, how these two connected, sir? In series or in parallel? Come on, engineers, in series or parallel? In parallel. Therefore, I am compressing this. Therefore, between these 2 points, I can represent a single parallel combination. Taking these 2 points, representing the parallel combination, sir. What is that parallel combination, DS? Z2 parallel Z3. Z2 parallel Z3. Come on, you tell me. For this point, what is connected? Z1 is connected. Here, Z1 is connected. This point is A. Here, what is connected? Z4 is connected. See, Z4 is connected like this. Z4 is connected what point? This point, nothing but. This point, nothing but. This point, nothing but. This point, nothing but. B point. See, I am connecting this like this. Okay, from here to B point. I repeat my statement, sir. See, this point we have taken and we have plotted this. Yes or no? Yes. This point, this point, this point, this point, same. Z4 is connected between this point and this point. How connected in similar fashion? Now tell me, sir, what is ZAB? Come on, it is physically appearing to you, sir. How this Z1 and this combination connected? In series. How this series combination is connected to Z4? In parallel. Finally, what is the answer? Z1 plus Z2 parallel Z3. Z2 parallel Z3. The total combination is in parallel with Z4. I repeat, Z1 plus Z2 parallel Z3 and the series combination is connected in parallel with Z4. What is ZAD for this question? Same answer. What is ZAC? Still the same answer. After going, yes please. After going home, in sense you are at home only, right? Yes. please open CD terminals, short A and B terminals. Looking from CD terminals, what is your answer, dears? What is your answer? Looking from CD terminals, what is your answer? Yes, please. If you short this A and B terminals, Z1 parallel with Z3. The combination is in series with Z2. The total combination is in parallel with Z4. Fine? Right. These are some questions on series parallel addition techniques. I can say like level 1 questions on series parallel addition techniques. Hope you enjoyed the lecture, dears. Thank you. All the best.